Hi everyone, my name is Rasul Bakhtovaza and I'm a first year PhD candidate at PRC, Sustainable Minerals Institute at the University of Queensland. And today I would like to talk about the application of machine learning algorithms in resource estimation. So the outline of my presentation is as follows. At the beginning, I'll introduce the research background, then I'll state the problem, and I'll talk about machine learning algorithm as a possible solution. And I'll talk about the motivations, why I think it's important to do, and at the end I will conclude. So the mineral resource quantification is usually commenced at the beginning of every mining project at the exploration stage, and is continuously used throughout the life of a mine. Generally, construction of block model can be done by two statistical methods, such as estimation, like kriging, for example, and simulation, like turning band simulation or other simulation methods. This short version of steps involved in estimation using geostatistics. So the first step is to obtain the variogram model of the deposit. Second one is to fit the model to the variogram, and the third one is to produce a block estimates, construction of block models using any of the available estimation or simulation techniques. So turning to the problem statement, as current active deposits continue to be depleted and outcropping mineral deposits become more rare, the exploration of new deposits is becoming more expensive and risky because the new undeveloped ore bodies tend to have more geological complexity, like non-linear relationship among the variables, and thus the spatial prediction of ore body characteristics by traditional geostatistical methods can often be very challenging. The problem of grade estimation is quite complicated due to the very complex, not very well understood process of ore body deposition. Most of the approaches to date, including the most important geostatistics, are based on certain assumptions about the spatial distribution of ore grade within the ore body, like second order stationarity, which assumes that the mean is known and the variogram reaches a seal. And the second issue is due to the big nugget effect, which is resulted from the complex correlation structure. It's very hard to fit the model with high nuggets. And also, geostatistical approach, sometimes they cannot work with non-linearity, so they are not efficient enough to capture the global non-linear relationships. The possible solution. Machine learning algorithms can be an alternative to handle these issues, since in the neural network, neural networks have been used to address numerous statistical problems because of their capacity to capture the non-linear trends. They can be used in the estimation of ore grades. No assumptions are made about any factor or relationship regarding the spatial variation of ore, given the availability of drill hole data. So there is no need to calculation of experimental variogram, and non-linearity can be captured globally. And also, machine learning algorithms can be used to capture features important for grade prediction and classification purposes. Turning to the motivation, why I think it's important to use machine learning algorithms for the grade prediction and classification. In geostatistical methods, spatial continuity are considered as the main factor in estimation. However, over the years, we have learned that there are other factors like geological structure, deposition, environment, type of ore, degree of mineralization, or lithological data that also need to be considered. And one of the abilities of neural network is to use multiple features as input data that can lead to significant improvements in more accurate or grade predictions. There are some cases when significant improvements are obtained when, besides location, information on the rock type is included in the set of predictor variables. This observation highlights the importance of carrying out the detailed studies of the geological composition of the deposit to obtain more accurate ore grade prediction. Another motivation why I think it's important to use machine learning algorithms is the big data. Big data is collected on mine projects, and existing data management and interpretation tools cannot cope with the quantity and variety of data collected. So machine learning algorithms can be used to optimize the outcome of the expensive data and allow their effective use in the exploration process. In conclusion, application of machine learning algorithm may result in more accurate grade prediction, which will be very useful for the further mining steps like mine investment decisions, pit design and grade control planning, and other steps. Machine learning algorithm can be useful in using the additional available information that are not used before for prediction of grade. In terms of sustainability, more accurate block models leads to less loss of energy, and also it can help in capturing important features in grade estimation. Therefore, the study of machine learning algorithms and their use in the prediction of grades and classification is very important, as it may handle the issues mentioned above. That is the end of my presentation. Thank you very much.